Ever wonder why a rocket launches into the sky, or why a speeding car comes to a sudden halt? Feel the pulse of the universe as we unravel the hidden forces behind motion. Newton's second law awaits, ready to unveil the secrets of how objects move and interact. What is Newton's second law of motion? Force is equal to the rate of change of momentum. For a constant mass, force equals mass times acceleration. Defining Newton's second law of motion. Newton's second law states that the acceleration of an object depends upon two variables c, the net force acting on the object, and the mass of the object. The acceleration of the body is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. This means that as the force acting upon an object is increased, the acceleration of the object is increased. Likewise, as the mass of an object is increased, the acceleration of the object is decreased. Newton's second law of motion says that acceleration gaining speed happens when a force acts on a mass object. Riding your bicycle is a good example of this law of motion at work. Your bicycle is the mass. Your leg muscles pushing on the pedals of your bicycle is the force. When you push on the pedals, your bicycle accelerates. You are increasing the speed of the bicycle by applying force to the pedals. Newton's second law also says that the greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. Say you have two identical bicycles that each have a basket. One bicycle has an empty basket. One bicycle has a basket full of bricks. If you try to ride each bicycle and you push on the pedals with the exact same strength, you will be able to accelerate the bike with the empty basket more than the bike with the basket full of bricks. The bricks add mass to the second bicycle. With bricks in the basket, you would have to apply more force to the pedals to make the bicycle with bricks in the basket move. Derivation of law. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the mass of the object. Acceleration is directly proportional to net force, and inversely proportional to the mass. So we can say, application of second law. Newton's second law is applied to identify the amount of force needed to make an object move or make it stop. Following are a few examples that we have listed to help you understand this point. Kicking a ball. When we kick a ball, we exert force in a specific direction. The stronger the ball is kicked, the stronger the force we put on it and the further away it will travel. Pushing a cart. It is easier to push an empty cart in a supermarket than a loaded one, and more mass requires more acceleration. Two people walking. Among the two people walking, if one is heavier than the other, the one weighing heavier will walk slower because the acceleration of the person weighing lighter is greater. That's it for today. Thank you for watching. Make sure to like, share and subscribe my channel.